think we can get started. So welcome to this session. We're going to talk about Kubernetes native development. And I don't know if you're familiar with this term. It's kind of, it's still software development, right? But our traditional way of development has typically or traditionally been like, yeah, I'm going to develop my code and it works great on my local machine, package it up maybe, throw it over the wall, and somebody's going to deploy it on these kind of big application servers, especially if you're like us and you're Java developers, and use as many resources as you want. It doesn't matter, we have these big servers. Kubernetes native development is kind of different, right? You need to think about the way that your applications are going to live on Kubernetes in a different way, because on these clusters, what you want is applications that start up fast because they can be kind of rescheduled or maybe scale up or whatever. Excuse me, and you want to make sure that the resource usage is going to be lower, right? Because the smaller your application is, the more you're going to be able to make the most of these clusters in terms of density and out of your money as well, right? So that's kind of what we need to think about as application developers, and that's what we're going to try to focus on a little bit in this session. Some tools that we can use in the CNCF landscape and a little bit out of that in the open source space to help application developers work with Kubernetes without being Kubernetes experts. So my name is Kevin Dubois. I'm a developer advocate at Red Hat. I've been writing software for the last 20 years. So I went from that more traditional world to the cloud native world. It's been an interesting journey, and with me here is Thomas.
Yeah, hi everyone. I'm Thomas Vitale. I work at Systematic, a Danish software company, passionate about anything cloud native and Java related. Wrote a book about it a couple of years ago, and now I'm working with my friend Mauricio Salatino on a new book called Developer Experience on Kubernetes. We're really excited. We just announced it yesterday, so the first few chapters are available out there. But let's get started. So Kubernetes native development. At least as a minimum, we want to work with containers somehow. So the first ingredient is we need a container runtime, where to run our containers on our local machine. So Podman Desktop is the tool we're going to use today. It's a great tool. It's open source. It's been donated by Red Hat as a CNCF sandbox project. So the donation process is ongoing. It's really great. We can run and manage containers in different ways, as we'll see during the presentation. We have an application, we have a container runtime. What do we do next? We have to package it as a container. We might go directly and write a Docker file, but in the Cloud Native ecosystem, we have a great tool. It's called Cloud Native Buildpacks. It works in this way. You don't have to write any Docker file. You take the source code, and doesn't matter what type of source code, you can use your favorite programming language and framework, because there's very wide support across different languages. And then using Buildpacks, for example, the pack CLI that comes with the project, you get the production-ready image. And this image will be production-ready. It will be designed and built in a way that is performant, that is secure. So as a developer, I get a really nice experience, because I focus on my application source code, and when I have to build a container, I just run one command. I don't have to write and maintain a Docker file, because writing a Docker file is easy. Writing a Docker file, which is production-grade, is not that easy. So let's give it a shot. I have a Java application as an example, but as you can see, it works with different types of languages. You can use the pack CLI directly that comes with the project, but lots of different frameworks also have Buildpacks built in. For example, in Java, we're going to see examples in Spring Boot and Quarkus. They both have Buildpacks support out of the box. So what I can do is directly from my application, I can containerize it. In this case, I'm running this boot build image task. And using Buildpacks, now I obtain a production-grade container image that I can just deploy to production. But first, I want to run it locally. So I have my image. I have Podman running on my local environment. So I can run my container image. Let's do that. I can say Podman run, and give it a port, 8080, and then the container image that I just built, which is called Buildpacks version 1.0.0. And now it's running. We can even test it. I can send a HTTP request to the root endpoint, London, baby. All right, it's working. What's next? We want to eventually deploy it to Kubernetes. Now, one way of doing it is provided by Podman Desktop directly, because with Podman, I can spin up a cluster very easily. If I go here in the settings, besides running Podman, I can actually create a cluster using Minikube or Kind. In this case, I use Kind to create a cluster. It's very easy. You can do it directly from the UI. You choose a name for your cluster. It even configures an ingress controller out of the box. That means that whatever application you're running in the cluster is also exposed to your local environment. So you don't have to deal with port forwarding and understand all the low-level details of how Kubernetes networking works. So you get a really nice out-of-the-box experience as an application developer. And once I have that, I could go ahead and define my Kubernetes manifest and all of that. But once I have a container, Podman has a very nice feature. So I have my container image down here. What I can do is say deploy to Kubernetes. So directly from here, I get all the manifest auto-generated for me. Let's say demo Buildpacks. I can provide different parameters, but all the defaults are fine with me. And then I can just say deploy. And now I have my application deployed as a pod in Kubernetes. I didn't have to write any YAML file. And I get also a nice Kubernetes dashboard directly from here, where I can monitor all the resources. And we should probably find our demo Buildpacks pod in here. And it's running. Now, this is really great. It's quite convenient. But if we have to do this every day as part of our daily development workflow, things might get a bit too slow. We really want to achieve a fast feedback loop, right? So there must be some better way of doing that.
Yeah. So we saw how you can deploy a pod to a local Kubernetes cluster, but of course, deploying a pod is not necessarily how you're going to go to production, right? You usually are going to need to deploy our good old YAMLs, right? At the very minimum, you're going to need to deploy to create a deployment. So you can see here kind of an example of a deployment and a service. So if you've already worked with Kubernetes, you're probably familiar with these concepts. But this is kind of the very minimum that you need for deployment to Kubernetes. And then with that, it's just writing some YAML, so it's easy, right? I mean, all our developers, they love their YAML. Not really. And then, but with the deployment and the service, you say, OK, we're going to go to Kubernetes, but it's not ready for production. And that's the key for developers to keep in mind. It's not just about deploying an application in a container to Kubernetes. There's more that we need to think about. So here's an example of an application that was deployed in a container, and it starts up, and it has a dependency on a Kafka cluster, has a dependency on a database, and you can see here that it actually takes 2.6 seconds in this case to establish the connection with the database and with the Kafka cluster. So in those 2.6 seconds, we're actually having a downtime because Kubernetes sees that the container has started up and it says, OK, cool, we'll send some traffic to the container. But of course, the application itself is not ready yet. So of course, what we need to think about is how to tell Kubernetes that we actually are ready to receive traffic. So in the Kubernetes world, you have these probes. You have readiness probes, you have liveness probes, and startup probes to tell Kubernetes that the application has started up, that it's ready to receive traffic, and that it's also still alive, right? So even after it started up, that if something goes wrong, maybe the pod loses the connection with the database or something that, well, at that point, we're not really alive anymore. So this is something that developers need to keep in mind because we need to provide this kind of information to our platform engineer, to our platform team, to say, these are the endpoints that you should call from Kubernetes to know whether my application is healthy to receive traffic. So, of course, again, a little bit of YAML. Then we probably want to integrate some sort of environment variables, maybe connection strings or database usernames and passwords. So that's something that you typically pass in via things like config maps and secrets. Whether you want to just use secrets or a vault or something that's kind of irrelevant, you do need to at least be aware as a developer, where are those values going to come from and how should I integrate those into my application as well. And then very kind of contentious issue with a lot of developers that I speak to is that they need to be aware of the resource usage of their applications. So they need to know kind of, let's say at least more or less, how much memory we're going to use, how much CPU we're going to use, because that allows the platform team to determine like how much space do we need to reserve for these applications in our Kubernetes cluster. So you can provide requests to make sure that, hey, I need at least this amount of CPU and memory, and then potentially limits, depends on who you ask, whether you should implement limits, but limits basically tell the Kubernetes cluster if the application goes beyond this usage of memory, then kill the pod, start it back up. Or if it uses more CPU, then start throttling it, right? So because there are other applications running on this cluster, we need to make sure that it's fair for everyone. So again, more YAML. So developers, they're not Kubernetes experts. They're not going to know exactly how to write all this YAML. So how can we help them? So in the Java world, there's some solutions in the general developer space as well. I'm going to talk specifically about a new Java stack that's Quarkus, where you can actually, as a developer, define, and I'm sorry if it's a little bit small in the back, but you can define in your application properties, something that Java developers are pretty familiar with, what kind of connections you're going to use, what kind of secrets you want to implement, what kind of container image you want to build, what kind of resource usage, and whatever more. So you can define that in your application properties, and then Quarkus can actually translate that into a Kubernetes YAML. So let's look at this in a little demo that I recorded. So this is a Java application, and I'm going to add a dependency, Kubernetes, and a Kubernetes config extension to my Quarkus application. And you'll see that in the target folder, a new Kubernetes folder is created with a Kubernetes YAML file. And you can see it has a service account, it has a role binding, it has to allow access to secrets, it has our deployment, and it has our service. So it generates all this YAML kind of for the developers, so they don't need to do all that. And then you can see here in the application properties, that's where we actually have those configurations defined. So we translate that to Kubernetes, a YAML file that we can then deploy. So here you can see that, for example, we also configured, our memory usage and our CPUs, and we have that. Then the health endpoints, we can also add those. So you add another extension for health, and it automatically configures health endpoints for you. It knows that you have a database dependency, a Kafka dependency, so it's going to add all those health points to make sure that you have a liveness check for your database, for your Kafka, and so on. And then going back to your Kubernetes YAML, you can now see that those liveness and readiness probes and everything are also added back to that Kubernetes YAML file, so it automatically kind of goes back and forth and make sure it's all added there. So this is not your grandma's Java, right? This is pretty cool stuff. And it also starts up much faster, it's much more smaller, so this is really kind of cloud native development. Here you can see you can use Quarkus to do the image push and also build. So it's going to build the application, build a container image, push it to a registry, and then now we can use Quarkus deploy to actually apply that Kubernetes YAML to a cluster. And so in a moment, we're going to see that it's generating some stuff. Now it's deploying all those different components, so service accounts, role bindings, and whatever more. And then it's deployed, and we can check that really there's the resource limits configured, the health endpoints, and everything. So, in terms of developer experience, this is what we're looking for, right? This is Kubernetes native development for Java developers. So now what about serverless? Because this is an interesting concept for developers. No more servers, right? At least not for the developers to necessarily worry about. So the promise of serverless is that you as a developer don't need to worry about, like how it's going to be deployed and how, more importantly, it's also going to be scaling. So with serverless, you kind of get auto scaling out of the box. So in the CNCF space on Kubernetes, there's a project Knative that does exactly this kind of promise, right? So it allows you to use serverless on Kubernetes. So I recorded another little demo And this time, because we talk a lot about Java, maybe we should branch out. So in this case, I'll create a Go application. So here you can see with Kubernetes, you can do k-and-func create, a name for the function, and then language Go, and that creates a function. You can use Knative with containers as well, but in this case, we're creating a function, then function build, and that's actually going to build our source code that it's scaffolded into a container image, and then push it to, or eventually push it to a registry as well. So here we can see that the function was built. You can see the source code that was scaffolded. So you, as a Go developer, can now kind of change the function to however you want. So if you're a Go developer, this should look somewhat familiar to you. So add your custom code here, and then you can build it and then deploy it. So k-and-func deploy is going to actually deploy, push your source code in a container image, push it to a registry, and then deploy that as a serverless function. So in this case, you can see I had to put my credentials to push it to a container registry, and you can see now it's deployed on Kubernetes, in this case OpenShift, and our application is up and running, so we can invoke it. So you can do that with Knative as well. So you can do knative func invoke to actually invoke the function. And you can see it gets, we get a nice response, or we can just use the endpoint that was exposed as well. So Knative also takes care of the ingress, so we don't need to worry about that. And you can see it responded, and we have, in the OpenShift case, it also created a route and a pod, which is now running. Now, if we wait a minute, we're going to see that because we're not calling the function anymore, it's going to notice that no more traffic is going to the pod, so we're going to scale it. And now there's no more pods running. We're going to wait for traffic to come in. So now I'm going to call the function again, and then we're going to see that it wakes back up, scales up a pod, or multiple pods in case there's more traffic. And so we have serverless kind of out of the box with just a few commands. And this is all running in Kubernetes with CNCF projects.
Yeah, and it's really nice because they're all polyglot tools. So under the hood, Knative Functions uses Buildpacks to build images that works across different languages. Yep. Knative Functions itself supports spinning up these out-of-the-box functions based on different languages. That's really great and seamless experience. But so far, we've been working with mostly with a single application. And when we start integrating, you mentioned Kafka earlier, or a database, things get more complicated because we can get it to work, having a single application containerized and deployed to Kubernetes, that's fine. But when we are in our development environment, how can we consume all these different application dependencies? It could be a database, it could be an identity management service. We have different options. Of course, one option is going this route, where we have a Kubernetes cluster, either locally or in the cloud, and we hook up our development environment on it. But do we really need Kubernetes for local development? Now, it might seem weird since we're talking about Kubernetes native development without Kubernetes, but let's take a step back. So across different languages, maybe you're using Java, or you're using Python, or you're using Node.js, we've actually been having very good developer experiences for a while. For example, in Node.js, I can say yarn dev, and my application is both compiled, is up and running, and every time I make a change, it's reloaded automatically. The same happens with Java or with Python. So maybe we can reuse some of that known development experience instead of inventing something completely different. But we still have the problem of how do we provide these dependencies. How about databases? We have different tools also that we can use in the cloud native ecosystem. One of them is Testcontainers. Testcontainers lets you run in a programmatic way lightweight containers as part of the application workflow, and we'll see in a moment a demo. We'll also have a look at Microcks. Microcks is also a CNCF project, and whenever you have to integrate and test against different APIs, it could be HTTP APIs, it could be asynchronous APIs, messaging, it's really useful. So let's try now to establish a development experience without Kubernetes for the local environment. Let's start introducing Testcontainers to the mix. As I said, Testcontainers is a polyglot tool, so maybe in Java, if you want to integrate with RabbitMQ, there's a way to declare that dependency, or maybe you're building a Python application and you want to integrate with Keycloak. Keycloak is a CNCF project for identity and access management. You can do it using Testcontainers. How about Go? Same thing. Maybe you want to integrate with a PostgreSQL database. You can define it programmatically. this is a nice alternative to a compose file. And as additional bonus, you can use this not only for testing, but also for development. So let's have a look at how it could work. I have an application now, that Java application. Let me zoom in. I run it as I would usually do. In the context, this is a Spring Boot application, so I'm used to run it with boot run, and I'm not changing that. I'll keep running the same command from the different folder right there. But now what's happening under the hood that my application is starting, but not just my application, because this application is actually using Testcontainers to provision an Ollama service. Now, Ollama is a way that you can use to run large language models locally. So there's lots of talks about AI at this conference. So what I'm doing here is actually integrating my Java application with the AI models. And I can show you, if I go in the container section here, we can see that there's an Ollama container that's provisioned by Testcontainers. So when I start the application, I don't just get my application up and running, I also get Ollama. So if I now go and test the application, let's ask a question. It could be, what's the capital of England? Because I'm really creative with questions. What's that? Oh yeah, it's like this. And now I get an answer. This answer is parsed by a model that is running in Ollama. And I can use this approach with any kind of dependency, both at the development time and the testing time. This is really great because it means I don't need a cluster. Because having a cluster locally means also that you're responsible for it.
Yeah.
So it might be really easy to provision.
This is kind of interesting here.
Right?
It says London was established in 1962. That's okay. Interesting.
Okay, this is great. So something is really wrong here, right? And when we use large language models, things get even more wrong. So I want to argue here, because we talk a lot about observability whenever we go in production. I would like to say that observability is not just for production. Using something like OpenTelemetry should belong to a development environment as well. Now, for large language models, it's extremely important to have some kind of observability on a local environment. But in general, normal feature development, I really would like to visualize whatever I'm coding. So why do I have to wait until it's in production to get a nice dashboard or maybe a nice trace so that I can see the requests flowing through the system? I want OpenTelemetry, full OpenTelemetry system running on a local environment. How can I do that? Of course, I can have a Kubernetes platform running locally, but we just talked about Testcontainers. So I can actually use Testcontainers also for establishing an observability platform. And that's what I'm doing here.
Yeah, and so for developers, this is really nice, right? Because they don't need to deal with, how to set up this entire stack on a Kubernetes and manage all these different components. So it's really nice that you can just run that.
Yeah, it's amazing. I have defined here in Java these two dependencies, one for Ollama and one for OpenTelemetry. And I got Ollama, as you saw. But let's investigate why we get a probably weird answer from the model. So what is running under the hood? I have Grafana up and running. You can see it's running locally through Testcontainers. I didn't have to configure anything. This is zero configuration, zero code. It's just out of the box when I run the application. So we can probably go and check the trace now for the application. And let's zoom in. So I sent a request to the chat endpoint that eventually called a very tiny model. This is a model from Hugging Face. It's called small LLM2 or whatever it's pronounced. So it's really small. So it's probably very prone to hallucination based on the task. It's important to try out and evaluate different models based on the task. And if we don't have this kind of observability, it's really hard to do that, right? Here we can see exactly what is going on under the hood and improve our application. And again, if you have a database, you have Kafka, you can follow all the traces locally without any extra configuration. All right. How about other APIs, though? Because we've been talking about third-party services, but we also have other APIs we want to integrate with.
Yeah, absolutely. So especially when we're running on Kubernetes, we'll most likely have distributed systems where they need to interact, right? So as developers, again, does that mean that we need to figure out an entire Kubernetes cluster and set up all the different components to try to test our application? that's a lot of work, right? So in the CNCF space is a new, well, a relatively new project, which is called Microcks, and it allows you to work with APIs, mock them, and then run them potentially also as test containers in your local development flow. But you can also integrate this project in your deployment flow, in your CI/CD flow, to mock some interesting data, to test service individually, and then automate your entire cycle based on the same sets of data that you were testing on your local machine. Now, this is a really interesting project. It also has an operator that you can deploy on Kubernetes. So it kind of spans the entire kind of life cycle from development to actually, you know, almost to production, because of course on production you don't want to be mocking your data, but it helps you kind of simplify this whole life cycle. This supports not just APIs, it also supports, for example, Kafka and messaging and all that. So it's in different protocols. So it's an interesting project. You can, of course, use the CLI to automate everything. There's different APIs, or you can use the nice user interface as well. So definitely a project that you want to check out.
Yeah, and that's a great combination. So we have a development workflow now where we can work on microservices in isolation, thanks to Testcontainers and Microcks. But how about production? So the moment we reach production, we want to bind our applications with the actual services. And there's a nice API from the Kubernetes project itself. It's called Service Binding API. And that is really great in order to separate the concerns, because as an application developer, I declare that my application requires, for example, a PostgreSQL database and an OLAMA inference service for large language models. But then the platform itself is responsible for fulfilling that request. So we have this very, very nice separation of concerns. Now, as a developer, I might write these few lines of YAML code in order to declare my intent, but we would also like to achieve a YAML-less approach, right? So if you have some kind of developer portal maybe in your company on top of your platform, you might even more simplifying this procedure. For example, here I have a Backstage instance. I can choose a certain golden path here. For example, I want to build an AI application. And I have the possibility to choose different large language model providers. Maybe I want to choose Mistral AI. That's a great provider because all their models are open sourced, Apache 2 licensed, so I can both use the cloud service, but also run them locally in OLAMA for development and testing purposes. Or I can choose OLAMA directly, I can choose the database, and now what happens when I bootstrap this project is that for the local environment I get all the test containers and Microcks configuration, but then when it's ultimately deployed to Kubernetes, then I get all the service bindings for the actual services. So once again, as a developer, I don't have to deal with config maps, secrets, and maybe ordering via ticket to the platform team like that I want provision a new OLAMA service.
Right, exactly.
Right? Okay, so we have these two main ways of going, right? We have the local development workflow based on Kubernetes. We saw also an alternative without Kubernetes, but ultimately it's all about developer experience.
Yeah, so to kind of conclude where we're at with Kubernetes native development, what we need is fast feedback loops to make sure that everything is working the way that we're supposed to, that we can get that same kind of experience that we're doing on our local development, that pretty much matches with what is going to happen on the Kubernetes cluster, that we can try to reduce the cognitive load of, you know, this whole kind of landscape of Kubernetes and all the tools around that for developers who like to focus on, you know, their actual development task, that they don't get overwhelmed with everything around that. And then finally, we want, sorry, we're both hitting the thing at the same time. And of course, we want developer joy, right? We want to make sure that developers are happy, focusing on what makes sense for the organization, because if developers are happy, they're going to create really cool solutions that are robust and that are going to bring, you know, good value to everybody. So I think that's it, right?
Yeah, thank you very much for joining us. And if you like our talk, please share the feedback. If you have any inputs for us, we would greatly appreciate to hear from you. You can find the source code. Also, I'm having another presentation with my friend Mauricio, also about developer experience, so feel free to join there. And thank you very much for joining. Yeah.
Thank you.